we start another problem of the friction chapter. Here it says the friction coefficient between the two blocks shown in the figure is mu. That means the friction coefficient here is mu. The floor is smooth. That means the friction coefficient here, mu, is equal to this floor is smooth. What maximum horizontal force F can be applied without disturbing the equilibrium. That means what maximum force can be applied until the small m starts moving left towards left and capital M starts moving towards right. So let's solve this equation. Let's say the tension here is T. The same tension will appear here also as T. Then we consider the smaller block. If we are now doing the first part of the problem, that is this one, consider the M as the free body diagram. We write that this is M and there is a tension T. There is a force F here. It's left. There is a reaction force R and there is a downward gravitational force mg, and since it is being pulled on the left hand side, so there is a frictional force towards right which is equal to mu mg. So for equilibrium, that means nothing moves. Equilibrium, the force on the right hand side, that is T plus mu mg, has to be equal to the force towards the left, that is the F, that is F. So this is one equation. Let's say this is equation A. Now we take the free body diagram, of the larger mass capital M. The free body diagram of capital M is like this. There is a tension force T and this friction force mu mg will work here towards the left as a action reaction. And there is no frictional force with the table. So for understanding, we write frictional force with the table is 0. So from here, we find that T is equal to mu m g. So from equation 1, from equation A, we can write T is self mu mg plus another mu mg, mu equal to F. So for equilibrium, F is equal to 2 mg. This is one answer. Second part of the question is, what will be the acceleration if of the two masses, if the horizontal force is doubled? That means second part is the horizontal force doubled, that means 2F in place of S. Again, in this case, if we take the smaller body as M, then the Force applied towards left is F, and force applied towards right is tension T. It's a new tension, it's not the same tension, it's a new tension T. Also, there is a frictional force of mu mg as usual. So from this diagram, we can write that 2F F minus T minus mu mg will be equal to mass of the body into its acceleration. From here, we get 2F is now 4 mu mg. 2 mg minus tension T. Tension T is anyway again mu mg. Mu mg minus, there is another mu mg here, mu mg. This is equal to ma. This is for first block, or from here we can write G. This is, I'm sorry, this, let us put it this way, say this tension is T1 in the earlier case, this case, this tension is T2. So, here we cannot write T, where we have to write T2. So, 2F is 2 mu mg minus new tension T2 minus mu mg equal to mu F. From here we can write 3 mu mg minus T2 is equal to ma. Again, here taking the bigger block of M, here we have the tension here T2. There is no frictional force at its bottom, but there is a frictional force here, which is mu small m g. And it has got an acceleration on the right-hand side, say A. So here tension T2 minus mu mg is equal to capital MA. Equal to capital M, because the mass of the bigger body is capital M. From here we find tension T2 is equal to capital M A plus mu small m plus mu small m g. So let's say this is equation, say 1. So now from equation 1, we get mg, that is 3 mg minus this tension T2 we have already obtained now. This is capital M A minus mu small m g. This is equal to capital M A. This is equal to capital M. This is equal to capital M A. Sorry, this was small m A. The equation here was small m. This we are using equation 1, which is small m A. From here we find 2 mu small m g is equal to capital M plus small m into A. So what is the acceleration? Acceleration A is equal to mu small m g that divided by capital M plus c. So this is the answer to this particular question. Fine. And today we shall use a few more minutes. Small problem, very small problem. It's a matter of understanding the problem only any numerics. Here, this problem says a block of mass m slips on a horizontal stable in the action of a horizontal force applied to it. Right? So, if we try to draw, there is a horizontal table on a floor. Table is on a floor, and a mass is not given. We can take any mass. It slips. Say this acceleration is A. It says the coefficient of friction between the block and the table is mu. That means coefficient of friction here is mu. Also says the table does not move. The table is fixed. This table is so heavy, it does not move. On the floor, find the total frictional force applied by the floor on the legs of the table. So what frictional force is applied on the table? This is the question. They have not asked the frictional force between the small body and the table. They have asked frictional force between the table and the floor. This problem is actually very easy. If this is n, then this reaction force is R is equal to mg. And let us say force F is applied. And this will have there will be let me take a different color. There will be a force in this direction between the body and the force, or what I can do, I can draw the small body here. The small body M. This moves with an acceleration due to a capital F. Force capital F, and there is a frictional force here. This is equal to R, where R is the reaction force. R is the reaction force, and downward gravitational force is mg. From here, we can very easily write the pulling force F minus the frictional force mu R is equal to mass of the body into acceleration. From here, we can write F minus mu R is equal to mg is equal to ma. Right? So this is one equation. The coefficient of friction between the block is the table does not move. Question is, do you need the friction coefficient between the table and the floor on the mass of the table? The table does not move. What they want to find the total frictional force applied by the table. So this is the question. Total frictional force applied by the floor on the table. Now, if you take the table as a free body diagram. Then this is a frictional force on the left-hand side on this mass. So there is a same frictional force here, which is equal to mu r, which is equal to mu small m g. Now the table is steady. Table does not move. The problem is given. It is given in the problem. If the table does not move, then definitely the same amount of force like mu r is applied by the floor. So definitely the floor applies a frictional force is equal to mu m g. The question was, find the total frictional force applied by the floor on the legs of the table. So total frictional force applied by the floor on the table is mu mg. Second question is, do you need the friction coefficient between the table and the floor? That means if there is a mu here, mu2, do you need it? Answer is no need of mu2. Or do you need the mass of the table? Mass of the table. Mass of the table. Also no need. Answer is no. And the friction force applied is mu mg. Now, here the question is answered, but let's go one step forward. When possibly we would have need them, the frictional force by the floor and the mass of the table. If the table also moved, if the table also moved, then only we would have needed mu2 and the mass of the table. Otherwise, we do not need this information. So that is where it ends. We shall see another problem of friction next time.